Today is day 15 of Unit 9. We started today with this warm-up, so pause the video and then play to check your answers. So this warm-up is similar to the problem we did the other day, excuse me, with the teacher picking problems from the list of ones that you studied and from ones that you didn't. So that's how you want to approach it. So first of all, how many draws would contain 2 red and 1 white marble? Well, I'm picking marbles. I can't repeat, and the order doesn't matter to pick marbles. So hopefully you realize that's a combination. So I'm picking 2 red from the 3 red. So that would be 3C2. And I'm picking 1 white from the 5 white. So that would be 5C1. And because we're picking red and white, we're going to multiply those. So 3C2 is equal to 3, and 5C1 is equal to 5, and 3 times 5 is 15. So in 2, we're doing almost the same thing. We're drawing 2 red and 1 white, which we know there's 15 ways to do that, except for now I want probability. So that's going to be my numerator. And then remember, probability, the total goes in the denominator. Well, there's, let's see, 8 total marbles, and I'm picking 3 total marbles. So that would be 8C3 should go in the denominator. When you type 8C3 in your calculator, you're going to see that that's 56. So 15/56 is the answer for number 2. Number 3, I'm going to keep that 8C3 because that's still the total. So I'm going to keep that 56. But now I want exactly 2 white. Well, I have to pick from the white, which is 5. And I'm picking 2, which leaves from the 3 red, if I'm picking 3 total and I've already picked 2, that means the last, the red one has to be 1. It has to be 1 red one. So 3C1 and 5C2 over 8C3. So 5C2 is 10 and 3C1 is 3. So 10 times 3 is 30. 30 over 56 is our probability, which simplifies to 15 over 28. Okay, so keep that in mind, how to do a problem like that in the future. You'll see them again. If we're doing something where you can't repeat and the order does not matter, and you're looking for probability, that's a combination divided by a combination. Okay, so then we went to page 15 in your packet. You'll need your notebook and your packet out. On page 15, you'll see that we have some problems. Well, first of all, on the top of page 15, there's a, if I can find it, there's a tree diagram. Okay, and that tree diagram on the top of page 15 is representing us expanding a binomial. Specifically, the one that's represented there is the quantity x plus y to the third. Now, the way that I know that is because there are 3 layers to that diagram. It starts off with x and y, so that would be x plus y to the first. But then we have x and y again. That would represent x plus y, the quantity squared. But what we have on our page is x plus y, the quantity cubed. Okay, now we didn't take a whole lot of time to talk about this tree diagram in class because we had shortened periods, but if we looked at that diagram and went through each one, all the possibilities, I'd have x times x times x, which is x cubed. I'd have x times y, which is x squared y. I have x times y times x, which is x squared y. I have x times y, which is xy squared. I have y times x times, that's an x, y times x, which is x squared y. I have y times y, which is xy squared. I have y times x, which is xy squared. And last, I have y times y, which is y cubed. So if I use that tree diagram to write my terms out, I would see that I have 1x cubed plus I have x squared, y, and a third x squared, y. So there are 3 of them. Plus the xy squareds, we have 1 right there, 2 right there, a third right there. So 3 of them. And lastly, I have 1y cubed. Okay, so that's how I can expand x plus y, the quantity cubed. Well, obviously we're not going to make a tree diagram every time we want to expand something. And also, if you recall earlier, a couple units ago, we looked at how to expand binomials using Pascal's triangle. So let's talk about how we could get these numbers here using the triangle. So we talked about the very first row, the initial row has a 1, and we call that row 0. And then we have a 1 and a 1, and that's row 1. And then we have a 1, 2, 1, and that's row 2. And hopefully you remember how to get these numbers. We start with the 1 and then the 1, 1. But then from there on, we add the previous numbers, the numbers from the previous row. So 1 and 1 make 2, 1 on each end. So 1 plus 2 is 3, 2 plus 1 is 3, end with a 1. And that's row 3. And I could continue to do that forever if I wanted to. So how do I get those numbers 1, 3, 3, and 1? Well, I use row 3 because I'm expanding to the third. So that's how we did it a couple months ago in class. Now today, we're going to talk about another way of getting those coefficients of, in this case, 3's, rather than using the triangle. Triangle's great, but if you're expanding to a high power, I don't think you want to write out all those rows of Pascal's triangle. So there has to be a quicker way. And so on page 15, there's a box there that says hint. It alludes to how we're going to get those coefficients of 3 in this case without actually writing out the rows of Pascal's triangle. And what it refers to is if I'm looking at this tree diagram. Now again, I'm not going to make a tree diagram every time, but if I made a tree diagram, I'm looking at it, I'm looking for, to get this coefficient here, I'm looking for the number of times that we're choosing 2 x's out of the 3 layers. So out of my 3 layers here, I'm counting all the times where I see 2 x's of the 3. So hopefully what you're realizing is that I'm choosing, I'm indicating, I'm purposely exaggerating that word. I'm choosing 2 x's of the 3 layers. So choosing, we know from this unit, another way of talking about choosing is combination. The order doesn't matter. We can't repeat. That's a combination. So rather than me doing Pascal's triangle and getting the 3's that way, what I could do is if I'm trying to get the coefficient for the x squared y term, and I'm going to get the x squared and the y the same way I have been. That rule stays the same. We talked about how this is the number you're expanding to, then the next variable goes down by 1, down by 1. The second term starts with 0, but then goes up by 1, up by 1. That rule stays the same. Okay, so I've already determined that I want x squared y. I just need to know the coefficient. So whatever I'm expanding to, which in this case is 3, that's going to be my n for the combination. And then whatever the exponent is for that first variable, 2 in this case, that's going to be my r. So 3c2 just happens to equal 3. So 3x squared y, that's my coefficient for the x squared y term. Now, you could also use the exponent for the second variable, which is a y in this case. So I could do 3c1. And 3c1 also equals 3. So you can use either exponent. It doesn't have to necessarily be the first variable. It could be the first or the second. I generally just always use the first, but it could be either. Okay, so that's how you expand using what we call the binomial expansion theorem. So the theorem says you get the variables the same way we have, starting with the exponent you're expanding to, and then decreasing for the first term, and then starting with 0 for your second term and increasing as you go from one term to the next. But to get the coefficients, rather than using Pascal's triangle, using combinations. Again, the first number is what you're expanding to. The r, or the second number, is the exponent for either of the 2 variables. It does not matter whether you use the 2 or the 1. So for this one, 3xy squared, same thing. If I know xy squared, and I want to get the combination to get the coefficient, I'm going to use 3 because I'm expanding to the third. C, either 1 for the exponent for the x or 2 for the exponent for y. So 1 or 3, C, 2, either of those equal 3, and that's where that 3 is coming from. Okay, so now on the bottom of page 15, we also did one more problem together. We looked at, it asks you to expand x plus y to the 5th. So I start with x to the 5th plus, I'm going to use combinations to get that number. So it's what I'm expanding to, 5, c, my exponent for the x, which is going to be 4 because I'm going down by 1. X to the 4th, and then y is to the 1st. Remember, they have to total whatever you're expanding to, which is 5. The other thing that you might remember that we talked about earlier when we first learned this was that second coefficient and second to last coefficient is always going to be the number you're expanding to. So 5c4 is 5. Okay. And then the last thing we talked about earlier when we first did this was that there's the mirror image thing happening. So once we get the first few terms and we get to the center, we can copy their mirror image to get the coefficients. So then I have plus sign. I'm going to do 5c3. It's going to be x cubed, and the y is going to be 2. They have to total 5. Plus sign 5c2 is going to be x squared, and the y is going to be cubed. Plus sign 5c1, x is going to be to the 1st and y is going to be to the 4th. And last plus, I'm ready for my last term, so just y to the 5th. Ran out of space there, so let's see if I can fix that a little bit. Okay, so I have x to the 5th plus 5 x to the 4th y plus 5c3 is equal to 10 x cubed y squared plus, now we've hit the center so we can copy the mirror image. So 5c2 is also 10 x squared y cubed plus the mirror image of 5 is 5 x y to the 4th plus lastly y to the 5th. Okay, and there's our expansion of x plus y, the quantity to the 5th. Now, if you recall earlier when we did binomial expansion, when we used Pascal's triangle, we did some more complicated ones. So let's talk about one that's a little more complicated. I'm expanding to the 4th. I'm going to use combinations rather than Pascal's triangle to get the coefficients, and I am going to substitute the variables in their right spot. So the very first term I know is going to be taken to the 4th power, and in that spot goes 2x squared. So 2x squared is in parentheses, and it's to the 4th. Coefficient is just a 1 here. Plus sign. I'm going to then use my combination. So 4c, remember it's going down by 1, so 3. In parentheses, substitute 2x squared, and that's going to be cubed. And then in parentheses, negative y is my second term, and that's going to be to the 1st power. Remember, they have to total 4. Plus sign, 4c going down by 1, so 2. Parentheses, 2x squared is substituted in that spot, and 3 is going down by 1, so 2. And then in parentheses, negative y, and that's going up by 1, so that's squared, totaling 4, 2 and 2. Plus sign, 4c, this is a 1. In parentheses, 2x squared is going to be to the 1st, and negative y is going to be to the 3rd. And lastly, plus sign, in parentheses, negative y is to the 4th. Okay, so I'm going to go ahead and simplify 2x squared to the 4th. So 2 to the 4th is 16, and x squared to the 4th I multiply gives me x to the 8th. 4c3 and 4c1 on the end there, or second to last one, they're going to be equal because they're mirror images. And remember, that's the number you're expanding to, which is 4. So 4c3 and 4c1 both equal 4. So 4, I'm going to cube 2x squared. So 2 cubed is 8. X squared cubed is x to the 6th. And then that's going to be times negative y. I'll simplify that further in the next step. plus sign. I did 4C3, and now I'm on 4C2, and 4C2, if you type that in the calculator, that's 6. So 6 times, I'm going to go ahead and square 2x squared, so 2 squared is 4, and x squared squared is x to the 4th. And that's times negative y times negative y is positive y squared. Next, 4C1 is 4, or you can look at it, the mirror image, which we already got there, 4, times 2x squared, times negative y times negative y gives us negative y cubed. And lastly, negative y times negative y times negative y times negative y, that's going to give me positive y to the 4th. So let me just clean up those couple terms. So I have 16x to the 8th. 4 times 8 times negative 1 gives me negative 32x to the 6th y. 6 times 4 times positive 1 is positive 24x to the 4th y squared. 4 times 2 times negative 1 is negative 8x squared y cubed. And lastly, plus y to the 4th is on the end. And that's my expansion. Okay. So oftentimes in applications, and by the way, there are applications for binomial expansion. We're not just doing this for fun. But oftentimes in applications, you really won't care about expanding the whole entire binomial. You'll just care about a specific term for one reason or the other. You might need just one specific term. And so we need to talk about how we would do that. So in this case, we're going to find the third term in the expansion of the quantity 4x plus 3y to the 8th. So just the third term, not the whole entire expansion. So go ahead and copy that in your notes. So if I care about the third term, I'm going to start off by substituting my 4x and my 3y. And I'll have to figure out what those exponents are for each of those. And I'm going to put my combination in the front. So I know my combination, we're expanding to the 8th, so it's going to be 8c something. So we need to figure out what the exponents are and what the r is for our combination. So now we need to think about this a second. If we were writing out all the terms, our very first one would be 8c8, and then it would be 8c7, and then it would be 8c6, and we just keep decreasing. Okay? Well, but I don't want all those terms, I just want the third term. So one way to do that would be just to count backwards and keep track of what you're counting. So third term, so 8c8 would be my first term, 8c7 would be my second term, my third term, that's the one I want, that would be 8c6. Okay, but the problem with that is that's not very efficient for us to count backwards and try to keep track of which term we're on. So if I'm counting on my fingers, I'm 8c8, okay, that's the first term. So I have 1 on my hand, and then 2 for 8c7, and then 3 for 8c6. But again, that's not very efficient. What if we were expanding to the 100th power and we wanted the 52nd term? Are we going to count backwards from 100, 100, 99, 98, and keep track on our fingers until we get to 52? I don't think so. So there has to be a more efficient way to do that so that we don't have to count backwards all the time. So if you think about that a second, hopefully you'll realize, and most students, in most classes, students realize, this is similar to when we were doing sigma notation, where we wanted to know the number of terms. And if you recall, we took the upper index minus the lower index and we added on 1, and that told us the number of terms. Well, similarly, if I take the number that I'm expanding to, which is 8, and I subtract the term that I want, which is the third term, and I get 5, I add 1, just like we did with that upper index minus lower index. So you have to include the term you're starting with or ending with, depending on how you think about that. That's going to give us 6. So 6 is the r. Okay, and that's how you can do that. So the term you're expanding to minus the term that you want, 3, plus 1 gives us 6. That tells me not only my r, but it also tells me my first exponent. And remember, they have to total what we're expanding to, which is 8, which means this has to be a 2. So that's how you're going to go about that. So 8c6, I'm going to get that from the calculator. 8c6 is 28. And then I'm going to take 4 to the 6th in the calculator, and that's 4,096. I know that's going to be x to the 6th. And then 3 squared I know is 9, and y is going to be squared. So if I multiply 28 times 4,096 times 9, I get 1,000,000. Let me just write it first here. 1,032,192, and then I have x to the 6y squared. So that is my third term. Okay. Now, we didn't have time in class to do this because we had shortened periods, but why don't you pause the video a moment and go ahead and try the fourth term of 6x plus 7y to the fifth. Okay, so if I want the fourth term, first of all, I know it's going to be 5c something. So I'm going to figure out the something by doing 5 minus 4, which is 1, plus 1, which is 2. So 5c2 is what I want. I'm going to take the quantity 6x and square it. And I'm going to take the 7y, and remember this has to total 5, so 2 is already there, so 3 is what I'm going to do with that. So 5c2 equals 10. 6 squared is 36, x squared. And the next thing I have there is 7 cubed, which we know is 343, and then y cubed. So now I'm going to multiply 10 times 36, which is 360. 360 times 343 gives me 123,480. So 123,480. And then I have that x squared y cubed. And that is my fourth term. Okay. So the last thing we looked at here in class today was, again, just finding specific terms, but they worded it a little bit differently. They didn't say like the third term or the fourth term. They said the coefficient of a specific term. So kind of same idea. We're going to approach it pretty much the same way, except for we weren't given the specific term number, so we don't have to figure out what the r would be. Instead, we were given the actual one of the variables from that term. So the x squared term, well, if I think about that, I'm replacing 2x in the x spot. And so if the exponent needs to be a 2, that tells me that I have to be squaring the 2x. Okay, and then my second term is a 3. And I know it has to total 5 because I'm expanding to the fifth, which means that has to be a 3. And so if I know that, if I know this exponent has to be a 2, then I can figure out my combination. So it's 5 because that's what we're expanding to, and it's going to be C2, or if you wanted to say 5C3, that would also be correct. Now, it says find the coefficient. 5C2 is 10, but 10 is not my answer. A lot of times students will say 10. 10 is only the coefficient before we take into account these numbers. And if there weren't numbers here and they were just variables, x and y, let's say, then 10 would be my coefficient. But there's more to it than just the 10 because I have numbers involved. So I have to square the 2 and get 4, and that's going to be x squared. And I have to cube the 3 and get 27. And then I have to take 10 times 4 times 27, and that is then the coefficient of that term. So if I do that, 4 times 27 times 10, I get 1,080. Okay, now this one didn't ask for the actual term. Think back, the last question said the fourth term and the third term, meaning I want the variables too. Here, I actually don't care about the variable, I just care about the coefficient, so my answer is just 1,080. If it wanted the actual term, the term itself, we would write 1,080 and then the x squared would go with it. Okay, but the actual coefficient is just the number in front of that. Okay, once again, we did not get time to go over this last one in class, but take a moment, pause the video and try it, and then play to check your answers. So this time, x to the fifth, y to the seventh tells me the 2x quantities to the fifth, and the negative 3y is to the seventh, and they should total 12, which they do. And then my n and r, well, it's going to be 12. And then 5 or 7, it doesn't matter which you choose. So I'm going to go ahead and figure out what 12C5 is. It's 792. I'm going to take 2 to the fifth and get 32. And that's x to the fifth. And I'm going to take negative 3 to the seventh, and that is negative 2,187, and that's going to be y to the seventh. So the last thing I'm going to do is multiply 792 times 32 times negative 2,187. And when I do that, I get negative 55427,328. So negative 55,427,328. Again, all they asked for was the coefficient, so that is my answer. Had they asked for the actual term, then I would write that number. And then I'd have my x to the 5th y to the 7th after it. Okay, so that's the actual term, but the answer to the question, the coefficient, is just that number. Okay, and that's where we stopped in class. So that's where we're going to stop here in this video. Your assignment is the binomial theorem worksheet, which you picked up in class if you were in class. If not, I'll have it posted on Schoology that you can print it off and use that. You're going to do that worksheet, the whole thing, and you're going to do page 19, just questions A, B, and C. Please do those for tomorrow.